All right, my friend, let's work through this beautiful geometry problem together very carefully. We have a quarter circle with center at point O, and inside that quarter circle, we have a right triangle POQ. We are told that the small segment QR has length 2 units, and the diagonal PQ has length 10 units. Our goal is to find the area of the shaded region, which is the part inside the quarter circle, but outside the triangle. Now, the first thing I always like to do in problems involving circles is assign a variable to the radius. So let's call the radius x. Since O is the center of the quarter circle, both OP and OR are radii, which means they have exactly the same length. Therefore, OP equals x, and OR also equals x. Now let's look carefully at the bottom side. We know that the entire distance from O to R is x, and we are told that the small segment QR is 2 units. Therefore, the remaining portion OQ must be x minus 2. Notice how we found that. We simply took the entire radius and subtracted the known piece. So now our right triangle POQ has one leg equal to x, another leg equal to x minus 2, and a hypotenuse equal to 10. At this stage, a very important theorem comes into play. Since this is a right triangle, we can apply the Pythagorean Theorem. Remember, the Pythagorean Theorem tells us that in any right triangle, the square of the hypotenuse equals the sum of the squares of the other two sides. So let's substitute our values. We get x squared plus the quantity x minus 2 whole squared equals 10 squared. Now, let's simplify this equation carefully. The quantity x minus 2 whole squared means we need to multiply x minus 2 by itself. Using the identity a minus b whole squared equals a squared minus 2 ab plus b squared, we obtain x squared minus 4x plus 4. Substituting that back into our equation gives x squared minus 4, x plus 4 equals 100. Now combine the like terms. X squared plus x squared becomes 2x squared. So we have 2x squared minus 4x plus 4 equals 100. Next, let's move everything to the left-hand side so that the equation becomes equal to 0. Subtract 100 from both sides. That gives us 2x squared minus 4x minus 96 equals 0. Notice that every term is divisible by 2. So let's divide the entire equation by 2 to make it easier to work with. We get x squared minus 2x minus 48 equals 0. My friend, before we continue, if you're enjoying this step-by-step explanation and finding it helpful, don't forget to hit the like button, subscribe to the channel, and leave a comment telling me where you're watching from. It really helps the channel grow and allows me to keep making more math lessons like this for you. Now, let's continue solving the quadratic equation. We have x squared minus 2x minus 48 equals 0. To factor this expression, we need two numbers whose product is negative 48 and whose sum is negative 2. Let's think about that carefully. Positive 6 multiplied by negative 8 gives negative 48, and 6 plus negative 8 gives negative 2. Perfect. Therefore, we can factor the quadratic as x plus 6 multiplied by x minus 8 equals 0. Whenever a product equals 0, we use the zero product property. This property says that if two factors multiply to give 0, then at least one of those factors must be 0. So we set each factor equal to 0. From x plus 6 equals 0, we get x equals negative 6. From x minus 8 equals 0, we get x equals 8. Now, let's pause and think about what these solutions mean. X represents a radius. A radius is a length, and lengths cannot be negative. Therefore, x equals negative. 6 is not physically possible, so we reject that solution. The only valid solution is x equals 8. This tells us that the radius of the quarter circle is 8 units. Once we know the radius, finding OQ becomes easy. Remember, OQ equals x minus 2. Substituting x equals 8 gives OQ equals 8 minus 2, which equals 6. So the two legs of our right triangle are 6 and 8. Everything checks out because 6 squared plus 8 squared equals 36 plus 64, which equals 100, and the square root of 100 is 10. So our triangle is perfectly consistent with the given information. Now, we can move on to the area calculation. The shaded region is the part of the quarter circle that remains after removing triangle POQ. In other words, shaded area equals quarter. Circle area minus triangle area. Let's calculate each piece separately. First, let's find the area of the quarter circle. Recall that the area of a full circle is pi r squared. Since we only have 1/4 of a circle, we divide by 4. Therefore, the area of the quarter circle equals pi multiplied by r squared divided by 4. Now, substitute r equals 8. We get pi multiplied by 8 squared divided by 4. 8 squared is 64, so this becomes 64 pi divided by 4. Simplifying gives 16 pi. Therefore, the area of the quarter circle is 16 pi square units. Next, let's calculate the area of triangle POQ. The formula for the area of a triangle is 1/2 multiplied by base, multiplied by height. Here, the base is 6, and the height is 8. Substituting those values gives 1/2 multiplied by 6 multiplied by 8. 6 multiplied by 8 equals 48, and half of 48 is 24. Therefore, the area of the triangle is 24 square units. Now we have everything we need. The shaded region equals the area of the quarter circle minus the area of the triangle. Substituting our results gives 16 pi minus 24. That is the exact area of the shaded region. If we want a decimal approximation, we can replace pi with approximately 3.14159. Multiplying 16 by 3.14159 gives approximately 50.27. Then subtracting 24 gives approximately 26.27. So the shaded area is approximately 26.27 square units. Let's look back at the key idea that made this problem work. First, we express the unknown side lengths in terms of the radius. Then, we use the Pythagorean Theorem to determine the radius exactly. After that, we computed the area of the quarter circle and the area of the right triangle separately. Finally, we subtracted the triangle's area from the quarter circle's area to obtain the shaded region. So our exact answer is 16 pi minus 24 square units, and the approximate value is 26.27 square units. If this explanation helped you understand the logic behind the solution, make sure to like the video, subscribe to the channel, and drop a comment below with the word geometry, so I know you made it all the way to the end. Thanks for solving this one with me, my friend, and I'll see you in the next math challenge.